Okay, let us see more examples still about finding the center of mass. Now this time I'm going to also an example of finding the center of mass and also center of gravity. When they ask you for the coordinates, you give it as coordinates. If they ask you for the, or you can give it as a point, no problem, as long as you state it. So find coordinates of the center of gravity of particles with weights. This and at points, this respectively. What we do, you summarize our formula. We say the x bar, y bar is given by, you get the weights times their corresponding coordinates, and then you sum. You sum the weights times their corresponding points over the sum of those weights you have. So that's all you need. Where I is weight 1, x1, x2, y2. That will to you sum them. This means you sum them, and this means you sum those weights. So if I'm summarizing the question, they are giving me, first of all, they are giving me the weights 5. So they are giving me 5 newtons. So weight 1, which is 5 newtons, is acting at a point 1, 0. Then weight 2 is 7 newtons, acting at a point 3, 0. Then weight 3 is 1 newton, acting at a point 6, 3. Then weight 4 is 3 newtons, acting at a point 0, 2. So there means that my x bar, y bar is going to be given. You get this rate times this times this times this times this, as simple as that over the sum. So here I'm getting now 5 times the point 1, 0. 7 times the corresponding point plus this times 6, 3, then plus 3 times 0, 2. All over the sum of these weights. We sum this plus this. So 5 plus 7 plus 1 plus 3. So what do we get up? This is 5 plus 21, that's 26. This is 32. So up we have 32. Then down, now this is the x coordinates. Then down we have 0, 0. That is 3 plus 6, that will give us 9. Now all over. What about the side? This is 10. We are getting 16. We are getting, this is 12 as 4. That will be 16 with ease. Then after that, you get this divided by that. It always simple as that. You multiply with the is, unless otherwise. This is 6 plus 3, that's 9. Then up we have 5, 26. This is the 26 plus 6, that is 32, as simple as that. Then after, feel free to separate. If you separate, this is going to be now, you get this divided by this, 32 divided by 16 over, then you also get this, divide it with this. So you get also 9 divided by 16. So 16, this is also 16. So up, we are getting, that is 2, and down, we get 9 over 16. So they asked for the coordinates, so our center of gravity is going to be at the coordinate x bar, y bar, which is going to be 2, 9 over 16 with ease. So there you are done. Now this one, find the coordinate of the center of mass. Now they are talking about mass. That's now I have M instead of W. W works for the center of gravity. Then the center of mass, we get the masses times their corresponding coordinates over the sum of those masses. So the first mass, so M1 is 5. The corresponding coordinate is 31. Then mass 2 is, mass 2 is 2 kilograms. 2 kilograms. corresponding coordinate is 4, 3. Then mass 3 is 2 kilograms also. 2 kilograms, corresponding coordinate 5, 2. Then mass 4 is 3 kilograms, then the corresponding coordinate negative 3, 1 with this. Then after that, what happens? We come for our x bar, y bar. What happens? We get the mass because we are on now the center of mass. If this was the one at the center of weight, then we now multiply this mass with gravity so that we get the weight, but they are asking for the center of mass. So we get the mass times this, 5 times 3, 1, then plus this times this, then plus 2, 5, 2, then plus 3, and that is 3, 1. The all over. Sum now this mass is 5 plus 2 plus 2 plus 3. Now, the other way, some people do, they get x bar first, then y bar first. It's okay, no problem. But I think this one's somewhere. It takes your time to handle it. So this one is going to be 15 plus 8, that is 23, plus 10, 33, minus 9, which is going to 33 minus 9 is going to give us 24. Then we have 5 plus 6, 11, 15, 18. So 18, those are the coordinates we have. And dividing the sum, this is 4, 9, the sum is 12 there. This is going to be now 12 divided by the 12, divided by the 12, then 8 divided by the 12 there. And so this will give us, that's going to give us a 2. Then here by 6, by 6 is 3, by 6, 2. I think we get 1.2. I mean 1.5. So by 6 is 3, by 6, 2. Those are the coordinates we have. So this is our x bar, y bar. By they asked for the coordinate. So because they were given, okay, our coordinates, so our center of mass is at x bar, y bar, which is going to be equal to 2, x bar is 2, then this is 1.5, well it is, and then feel free to underline. Okay, when I come to this, find the position vector. Now here they're asking for the position vector of the center of gravity of particles with weights and position vectors. So we summarize our weight 1. Now they're asking for the center of gravity. That's why they are giving us also weights there. So our weight 1, they are telling us 7 newtons. Its position vector now in the column form is 4, 1. Our weight 2 is, our weight 2 is 9 newtons. Its position vector, you see this is there, so meaning its x coordinate is 0, then this is 3, then our weight 3 is 4 newtons, the corresponding coordinate is 3, 4. Then we come and calculate our center of gravity. We get x bar, y bar, this times this, plus this times this, plus 4 into 3, 4. The all over the weights 7 plus 9 plus 4. When we simplify up, we have this is 28 plus 12. That's going to give us 40. Then we have 7 plus 27, that is 34. Yeah, this is 7 plus 27, that is 34, plus 16, which is going to be 50. 50. Then down, when we sum these ones, we get 20. And this is going to be now 40 over 20, then 50 over 20. So now our x bar, y bar is going to be, see up we have 2, then here we have 2.5. Now they ask for the position vector, not the coordinate. The position vector now, we can leave it there, or we say our x bar I plus y bar j is going to be 2I plus 2.5j, because we are leaving it in the ij notation. As simple as that. So that's how we handle. These are basic things. There is nothing hard in these solutions here. That's it. I wish you well.